So, today we're talking about surface area again. All right, so you got a little bit of experience with surface area yesterday. Can you tell me, what is surface area?
It's the surface of the area.
Say it again?
Oh, no, it was
the area of the surface.
The area of all the surfaces. Yeah, I just wasn't sure because, you know, your mouth is full of banana bread. It's the areas of all the surfaces. Areas of all the surfaces. Add it up. And so you have to think, about all the different sides of the shape and how it's formed. But if you can think that way, then it's pretty good. Now, I did mention that there's all kinds of formulas that we can use, but I don't like teaching a formula when it's just unnecessary, okay? And so if you want to use this stuff, you can. It's not terribly hard to figure out, but I'm not going to do it that way. I'm going to do it just the brute force way of just finding all the different shapes and adding them up, okay? Because that's the easiest way. You don't have to remember anything extra. If I can see what shapes are here, well, I'm going to start with number 2 here. Looking at number 2, what are the different shapes of that square base pyramid?
Square, triangle.
A square and how many triangles?
4. 4 triangles.
4. 4 triangles. There could be 2 different types. You're right, there could be 2. This one does not have 2 different types.
I was just thinking to see the dotted line.
Yeah, so there's this front triangle, a left side and a right side, and then the back side. So there are 4 triangles, and they all happen to be the same. Those triangles all happen to be the same size. They might not be, so you do have to be a little bit careful sometimes. If it was a rectangular base, those triangles would be different sizes, okay? So you do have to be a little bit careful. How do we find the area of our square base here? Yeah, base times height. It's a 5 by 5, which means what's its area? 25, or 5 squared, yeah. And then the area of a triangle. How do we find the area of a triangle? Yeah, a triangle area is 1/2 base times height. And so we got to use our little triangle formula. And so this is nice. They're giving me this dotted line here. That is what is known as the slant height. And that slant height is telling me that the height of the triangle that it is laying upon. Does that make sense to you? It is giving me the height of this slanty triangle, and I need to know that. So if I'm going to figure out that area of that triangle, I'm just going to do it over here, I guess. 1/2, the base is 5, and the height of the triangle, and that is the slant height of the triangle there. That's how tall that triangle would be if you laid it flat on the ground, is 7.4. So let's see what that is. 1/2 times 5 times 7.4, and I'm getting 18.5 for the area of my triangle. 18.5. That's the area of one triangle. What do I need to do for all 4 of them? 4 because there are 4 triangles. There we go. So we're going to do 4 times that 18.5. All right, and then we're done. So that is our surface area. So 25 plus 4 times 18.5, and I'm getting a 99 inches squared. All right. All right, so they gave me the height of those triangles, but on number 3, what's different?
They only gave us the height in the base of the triangle square.
Okay.
They gave us like the point height.
Okay, the height of the point, that's true, yeah. The height in the middle, the height at the point or the peak of the pyramid. So they're giving us here, this 3 feet is the height of the pyramid. That is the peak of the pyramid, but that does not tell me the height of my triangle, which is right here. This is my slant height that I need to know in order to find the area of that triangle. So I'm going to just call it the cursive L. That's what we do for slant height, so S-L-A-N-T. So that's the L for slant height. But once again, I mean, basic work here, I need to know the area of the square, and then there are 4 triangles that I need to figure out the area of, right? So that's the general rule here. I have 1 square and 4 triangles, but how do we figure out this slant height? Nope. All right, there's my slant height. It wasn't quite at the center. It was irritating me. All right. What if I connect from the very center point here, where the height of the pyramid connects right in the middle, and then hey, look at that! I created another right triangle there. Do you see that right triangle on the inside of the pyramid? It's always Pythagorean theorem. Always. It's always Pythagorean theorem. All right. So ladies and gentlemen, what we have is a triangle with one leg that is 3 feet tall. And then I'm trying to find the slant height L right there. What is the length of my line that I added in here? 8. Very good. Why is it 8? Half of 16. It's only going from the center out, so half of 16. And then what are we going to need to do? Pythagorean theorem. So leg squared plus leg squared equals my slant height squared. Let's see, that's 9 and 64. Oh my God, you guys. 73?
Yeah.
Oh my God. That was really hard this morning. Okay. And then how do we get L by itself? Square root, both sides. So I'm just going to leave it as the square root of 73. That doesn't simplify, as it turns out. All right, so my slant height now is radical 73 for a length. I don't know what that is. It's like 8.5, maybe 8.6, something like that. All right, so, okay, now that I have the slant height, now I can figure out the area of my triangle. So let's find the area of my triangle. 1/2 base times height. And what's the base of our triangle? 16. And then the height of my triangle, so that is that slant height there, which is radical 73. All right, so 1/2 times 16 times radical 73. Whoops. There we go. And I'm getting 68.352. All right, so now I know the area of my triangles. So how do I find my surface area? Okay, we need, here's my square base, which is 16 by 16. So what's that area? $256. That'd be 16 plus 16. 16 times. 256 plus 4 times the 68.352. All right, so I'm going to go ahead and just do this all on my calculator. I encourage you guys, do not round. So you'll see what I'm doing here in my calculator. There's my 68.352. Don't round it off. Delta Math will get you every time for rounding off. instead go up and highlight and hit enter, and it'll grab the whole decimal for you and bring it down to get a very nice answer, one that doesn't have a ton of round off error. So 529.41 if we round to the hundredths place. That would be feet squared. Okay, how are you doing with this? Is it okay? Ready to move on to cones? Let's see. Oh! Let's see, we can skip applications. All right. Let me see here. What about, we haven't done one like number 4 or 5. I think we have basically everything. Let's do number 5 here. So number 5 is a different type of pyramid. This is a triangle-based pyramid. So it has this base triangle in green. So there's a green triangle. But then it has the tall triangles. And those are much taller. And how many of those tall triangles are there? 3, yeah, 1 for each side of the base. So there are 3 tall triangles. I'm going to draw it that way. So it's important we understand that those are not 4 of the same size triangles, right? Okay, so we got to be really careful. All right, so the green triangle has, we're going to do 1/2. What's the base of the green triangle? 7, right here, base of 7. And then what's the height of the triangle? 6.1. See the dotted line there? It's pointing and it's at 6.1. All right, so be careful. We don't want any slanty heights there. We want perpendicular to each other. So that is our base and height of that green triangle right there. All right, and then for my tall triangles, I have 3 of them. And I'm looking at the tall triangle here. What's the base? Also 7. So 1/2 times 7. And then what's the height? Yeah, that's that dotted line right through the center. That's the height at 12.2. 12.2. So 1/2 base times height for each triangle. And then this one we put a 3 in front because there's 3 of them. Do you have questions for me on that? Okay. Let's see. So I'm just going to put this whole thing in. 1/2 times 7 times 6.1 plus 3 times 1/2 times 7 times 12.2. So got that whole thing on in there, and that is 149.45 centimeters squared. What is number 6? Hexagon base. And what is this? But what is it telling me? Square yards, which is a measure of area. Yeah, that is, they're telling me the area. So I don't have to calculate it. Okay, that's kind of nice. So we have our, for the surface area here, we have our hexagon base, which they told me is an area of 93.53 square yards. And I knew, why did I know it was area? Because of the yards squared. The units told me. Units for area, all right? So those units are telling me that that's the surface area of the base. And then I have my triangles. How many triangles do we have? 6. And do we know that they're all the same? Why do we know that? Okay, well that means that they're all the same height. But what about their bases? How do you know that the bases match? They all have congruence markings. So this is 6 yards, and the congruence markings go all the way around. So every triangle there is the same. So there are 6 of our triangles. So we're going to add 6, and then how do we find the area of a triangle? 1/2 base times height. What's our base of our triangles? Yes, that base is 6. And what's the height? And they gave us that slant height there of 11.3. All right. So I can put that all in my calculator here. Now, what would we do? You know, like people used to be so smart, and now we're just not, because they would have calculated all of this by hand. All right.
But we're smart for using our tools.
All right, so 296.93 square yards. All right, do you guys have questions for me? Okay? All right. Yeah. Yeah. We totally are.
I don't know my multiplication stat.
I mean, would I be able to survive out in the wilderness? No. No. I think I would rather starve than kill an animal. Like a lot of you guys hunt. I don't, and I don't think I could get my hands in there and like do that, you know.
First time drop, the second one.
Okay. I don't even know. Maybe I could fish. You know, fishing's okay.
Fish
But
don't feel it. They don't feel when you...
oh, that I don't know about that.
They don't. They have
Okay.
no nerves. They have no nerves in their brain.
All right, ladies and gentlemen, I digress. There we go. All right, so surface area again. Now, the formulas you do need to know, because these sides are not all plane figures. They're not flat shapes that just are folded up. They're not flat. The cone has a curved edge to it, okay? So because it has a curved edge, we have to use a formula. And so once again, where does this surface area formula come from? Well, what is pi r squared? The area of the circle. That is the area of the circular base. So that's easy. So there's the area of the circle on the bottom. And then pi r L. So L, again, is the slant height of the cone. All right, that is the slanty height, not the perpendicular height, but the slanty height. It's a little bit taller than the height if you were to hold them up side by side. If we know the slant height, then the area all the way around the sides of the cone is pi times radius times that slant height, which is kind of nice. And so not too bad, but easy formula here. Let's do number 8. What is the radius? Half of 27. 27 over 2, which is 13.5? 13.5, okay. And let's see, I guess, what's 32.9? The slant height. So 32.9 is the slant height. And so we have everything we need for our formula then. So surface area is pi times radius squared plus pi times radius, 13.5, times the slant height, 32.9. Once you get that written down, it's all calculator work from here. So let's see, pi times radius squared. Oh, I don't like how that looks. Let me do it that way. There we go. All right, plus pi times 13.5 times 32.9. You can see I'm just using parentheses instead of the multiplication symbols. Easier. All right, and we get 1967. Good year. 0.89. Millimeters squared. All right. Ooh, we have to do a number 9. Pythagorean theorem. Why do we need to do the Pythagorean theorem? We need to find the radius. We need the radius. So yes, we needed to do The Pythagorean theorem, again, we have a right triangle here. All right, so legs squared. So r squared plus, our height is 25.2. 25.2 squared equals, I should have drawn my radius the other way, so this is a little more straightforward here. There we go. There's my radius on the other side. There's my triangle. Leg squared plus leg squared equals hypotenuse squared, so 27.3 squared. All right, let's see. So what do we need to do? Minus the 25 squared. All right, so I'm going to do that. 27.3 squared minus 25.2 squared. And I get r squared equals 110.25. And then what? Square root both sides. So I'm going to take a square root of my answer. And I get, hey, look at that. 10.5. How perfect. All right, so my radius is 10.5, and my slant height is the 27.3, and that's what we need. So surface area is pi times radius squared plus pi times radius times slant height. There we go. Good? All right, so we get pi times 10.5 squared plus pi times 10.5 times 27.3. Oh, you can't see me typing. There we go. All righty, and we get 1246.90 inches squared. Last one we're going to do is number 10. Number 10, we're going to do if a cone has a surface area. So first of all, it's a cone. Do we have a formula for surface area of a cone? We sure do. I'm going to write it down. Surface area is pi radius squared plus pi RL. We have a formula. Write it down. And then what are we going to do with the 822.78? Plug it in for, yeah, it says surface area is 822. So that's going to go in for surface area. And it says a diameter of 18. How does that help me? Yeah, the radius is 9. So that can go in for the radii there. And that's going to allow us to solve for the slant height. So we have 822.78 equals pi times 9 squared plus pi times 9 times the slant height of L. Everything is filled in except the slant height. So this allows us to solve for the slant height. How are you going to do this? Not quite. This, let me see, we can clean this a little bit. I don't really want to, but let's see. So pi times 9 squared is, let's see, so 822.78 equals 254.469 plus 9 pi L, all right? So this 254.469, what do we have to do? Subtract it, yes. So I'm going to do, we have to subtract that to the other side. I'm going to do my 822.78, and I'm going to subtract my big long answer there, because again, I don't want to round until the end. So I'm subtracting my big long answer of 254. All right, so that gives me 568.3109 equals 9 pi times L. Now, how do we get L by itself? Divide by 9 pi. We want to divide by all of 9 pi. We want to get rid of both of those. Now, this is a tricky part. You need to be absolutely careful when you divide because we want to divide by the whole 9 pi. So, to be very careful, we're going to put parentheses around that. So, I'm going to take my 568. I'm going to divide by the whole 9 pi. See how I'm using parentheses there? And so we can get L is 20.099 centimeters. So I want you to see what happens if I don't divide with parentheses. So here's my 568. If I divide by 9 pi, all right, you need to understand what your calculator is seeing, not what you're thinking the calculator is thinking, okay? Look at that. You get 198. It's a very different answer than 20, right? What is it doing? Why is your calculator getting a huge number compared to the 20 that we should have gotten? Yes. It's reading, okay, take your number, divide by 9, then multiply by pi. All right? Instead, you could take your 568, you could divide by 9 and divide by pi. We want to make sure we're dividing by both things. Now the calculator will give you the right answer. Okay? It has to divide by both. Isn't that interesting? It's so important that you know how your calculator works. But we want to divide by both the 9 and the pi. So you can literally tell it to divide by the 9 and divide by the pi. Or you can put parentheses. Which way do you like? Parentheses? Yeah. So be careful doing that as you go. You have questions for me? All right.